0.63 grams of lead powder were dissolved in excess nitric acid to form lead nitrate solution, or the lead nitrate solution was reacted with sodium sulphate solution. Write an ionic equation for the reaction between lead nitrate and the sodium sulphate solution. Write ionic reaction, ionic. So before I write ionic, let me write the reaction that took place, the general reaction. So this is lead nitrate reacting with sodium sulphate. So this one is a double decomposition reaction. They will interchange the anions. This both of them are aqueous. They will interchange the anions, forming an insoluble salt, which is lead sulphate, plus sodium nitrate. So what happens here is that the metal here takes the cation here takes the anion this side, and the anion this side combines with the cation this side. That's what happens here. So this one is a solid and this one is an aqueous, because all nitrates are soluble. So once you have written like this, you are supposed to rewrite this equation ionically. So you will say lead 2 positive plus 2 nitrates minus plus sodium positive, which is 2 of them here, plus the sulphate 2 minus will give us, this one remains lead sulphate, because if it is in solid form, liquid form and the gaseous form, you don't write the ionic for that. If it is in liquid, gas or solid, you don't touch it ionically, it just remains. Then this one, as you can see, it is aqueous, therefore it will form 2Na positive plus 2NO3 minus. So there are ions you are seeing on the left side, and they are appearing at the same time on the right side. Those are called spectator ions. They cancel out. They have no importance there. So the spectator ions, as you can see here, we have sodium, 2 sodium, 2 sodium, nitrate, 2 nitrates, 2 nitrates. So those are called spectator ions. So what remains now is lead 2 positive, which is in aqueous state, plus the sulfate ion 2 minus aqueous state, and this one forms lead sulfate solid, and this is the ionic equation. That is the ionic equation. So for example, I can do a more example on the same. If you are given, for example, barium nitrate plus sodium sulfate, this one will form barium sulfate plus sodium nitrate, 2 of them. So ni muhimu sana kujua kuandika the aqueous, AQ, solid, liquid. Unajua aje? Yasema huo umeelewa what we call solubility of salts, the solubility. So this one is aqueous, this one is aqueous, this one is S, this one is aqueous. Now simply you write the ions which forms the solid only. So you just write here barium ions aqueous plus the sulphate aqueous, which will form barium sulphate solid, and this is the ionic equation. So once you have understood, you can simply write, you only write the ions which forms the solid, that's all, or the ions which forms the liquid, that's all, and you are done writing the ionic equation. Determine the mass of lead salt in A above. The mass of lead salt in A above. So let us get the mass of lead in A above, the mass of lead. Lead that was used, we need to get the information from the question. So mark it down that we were told that 0.63 lead, so 0.63 lead were used. And from the equation, as you can see, the ratio is 1:1 everywhere. So the ratio is 1:1. The lead sulphate that was formed and the number of moles of lead will be equal to the number of moles of the lead sulphate that was formed. You need to know that. So we need to now calculate the mass of lead, the moles. So moles of lead is equal to mass of RFM. But this is zinc, it is RAM. Now this one will be equal to 0.63. We divide by 207 because the RAM is 207. This one gives us 0.003 moles. So we are asked to find the mass of the salt that was formed. The salt that was formed is lead sulphate. So first let us get the RFM of lead sulphate. So RFM of lead sulphate itakuwa ni, this is 207 plus 32 plus 16 times 4. This one will give us 303. So 303 is the RFM of lead sulphate. But how do you calculate mass of a substance? So mass is equal to RFM times moles. So the mass will be equal to 303 times the number of moles, which is 0.03. Why did we use 0.03? Because the number of moles of lead will be equal to the number of moles of the salt that was formed. So this one gives us 0.922 grams.